So this problem here is actually pretty nasty, and it doesn't strike me as a GRE ETS question. So I'm not sure where you got this from. It's not a bad question. It just doesn't initially strike me as a GRE ETS question. So I would be interested to know where you got it from. If it is an ETS question, it's definitely a nasty one, and it's something that I would imagine most people would get wrong. So anyway, I'll kind of walk you through my thought process here. So set x is a set of n distinct integers. So we have a set of numbers labeled x. So let's just put brackets here. And it says there's n integers, and n has to be bigger than 1, and the integers have to be different because distinct. So I'm just going to put 1 and 2. Keep it easy. And it says p is the mean of set x. So the mean would be 1.5, but not a member of set x. So this is true. 1.5 is not a member. But I don't really want to deal with decimals. That's not really my game. So let's change the 2 to a 3. And so now p equals 2. All right, so we're on board there. So we have to determine which one of these will be true. So can I falsify any of these? Can I prove any of these false? So first of all, let's actually calculate the standard deviation here, at least the calculation that the GRE requires, which is the population standard deviation. And really what you're doing is you're just finding the difference of each value here to the mean. You're squaring that, and then you're taking the average of that, and then finally you're taking the square root. So let's actually do that. So if 2 is the mean, how far away is 1? Well, 1 is only 1 away, so let's square that. Okay. How far away is 3? 3 is only 1 away too, so let's square that, and that's going to equal 2. So now we need to take the average of this. Well, there's only two numbers, 1 and 3, so that's going to equal 1, and then the final step is we take the square root of 1, which equals 1. So the standard deviation here is going to be 1. Okay? Now, look at number 3. The standard deviation of set x is not a member of set x? Well, 1 is a member of set x. So we can eliminate number 3. Let's now look at number 1. The range of set x is greater than the standard deviation of set x. Because these integers must be distinct, you can put them from low to high, right? So for example, I could say 1, 2, 3, 4, 5, for example, and the range is going to equal 4. So now I need to calculate the mean, and the mean is going to be 3. I mean, it's pretty obvious. And so now let's calculate the standard deviation here. And the standard deviation, just at first glance, should be smaller than 4, and let's examine why. The standard deviation is calculated by measuring the distance from the mean to these numbers. And notice, because the mean's in the middle, the distance is going to be smaller than the distance from 5 to 1. Okay, you see how that works? So just my guess is the range is going to be bigger than the standard deviation. Well, let's go ahead and calculate it. So 1 is 2 away, so let's square that. 2 is 1 away, let's square that. 3 is 0 away, let's square that. 4 is 1 away, let's square that. And then finally 5 is 2 away, let's square that. And that's going to equal what? 4 plus 1 plus 0 plus 1 plus 4. And that's going to equal 10. Take the average of that, so divide it by 5, and you get 2. And then finally take the square root of 2. That's going to equal about 1.4. So 1.4 is lower than the range 4 here. So it looks like the range is greater than the standard deviation of set x. And that's also true here because the range is 2. So I have two examples here, which I think reasonably confirm it to be true because we have these distinct integers here, like that. Now, just to double check, let's use some negative ones because we don't want to, mess up with some negative integers because it doesn't say positive, right? So if I take, for example, -1 and -3, okay, what is the range? Well, the range is the big number minus the low number, so it's going to be -1 minus a -3. That's a positive and a positive, and what do you get? You get a 2. And then the standard deviation, the average here is -2, and because of the squaring process, the standard deviation is going to work out to be the same. It's going to be 1. So it looks like we're pretty good on number 1 here. It looks true. All right, number 2, if set Y contains all the members of set X. Okay, so set Y contains all of the members of set X, which is 1 and 3, plus P, so that would be 1, 2, and 3. The standard deviation of set X is greater than the standard deviation of set Y. Now, I could calculate this, but I could also just think about it. By adding in this 2, the distance from here to here is 1, from here to here is 1, which is the same right here, right? Same. But now I have this 0 distance. Because that 0 distance is being factored in, it should be smaller than this standard deviation over here, right? I mean, but we can calculate it. So the difference between 1 and 2, which is the mean, 2 is the mean, is 1, so 1 squared, plus 0 squared, that's the distance, plus 1 squared again, that's going to equal 2. Divide that by what? Divide that by 3. So we get 0.67. And then finally, we're going to take the square root of 0.67, which is definitely going to be less than 1, like that. So yeah, it seems like this is also true, number 2. So you can kind of attack this with examples. You can attack it with just thinking about it conceptually. Maybe you can attack it from a more kind of mathematically sound angle. But from my choosing number strategy, it appears that the answer is 1 and 2. And I also threw in a little bit of conceptual kind of just reasoning out in there.